Good morning. I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next lecture of wireless and mobile communication. So, the topic of today's lecture is GSM channel, that is Global System for Mobile Communication, and we are going to see various channels that is associated with this GSM. So, these are the contents of today's lecture, that is GSM channel. So, these are basically divided into two types, logical and physical channels. So, these are being discussed, we are going to discuss in this lecture. So, first we will discuss what is radio interface, that is related to channel only. So, radio interface is the general name of the connection between the mobile and the base transceiver station. So, basically let me remind you what is the basic theory behind this GSM. So, in this GSM, this is a second generation wireless mobile communication that is used for the transmission of voice signals as well as for the transmission of data also. So, what we are going to see that first we require a this is ME, that is mobile equipment, a simple mobile phone which is required to transfer the voice signals as well as the data. Now, this is connected to a BTS. So, BTS is nothing, it is base transceiver station. So, more than one ME is connected to single BTS. So, this will be an ME, and then more than one BTS is connected to single BSC. Now, what is BSC? BSC is base station controller, that will going to control the working of this BTS, that is base transceiver station. Now, more than one BSC is connected to single MSC, that is mobile switching center, and to this mobile switching center there are 4 different registers which are connected, which is responsible to carry the information related to the identity of the subscriber as well as the identity of the subscriber when it is visiting another cell. So, it consists of HLR, that is home location register, then visitor location register, AUC authentication and equipment identity register. So, these are the 4 registers that are connected to MSC. Now, more than one MSC, that is mobile switching center, there is connected a GMSC, that is global mobile switching center, and the last part of this GSM system is the out network, that it can be a PSTN, that is public switch telephone network, it can be a data network, it can be your ISTN. So, this is how the flow of this GSM architecture looks like, where a single mobile phone is connected and it can transfer the information to any of such places, like it can be PSTN, it can be ISDN, data network and so on. So, what is radio interface? So, radio interface is basically when a mobile phone is connected to a BTS like this one, there is some interface, air interface exists between these two equipments, and also interface is there between BSC to MSC, or it will be there between MSC to all the 4 registers. So, this is all about the interfacing that we are going to see. So, radio interface is the general name of connection between the mobile phone and the base transceiver station, that is nothing which is BTS. Now, it utilizes the TDMA concept, that is time division multiple access concept, with one TDMA frame per carrier frequency. So, in case of TDMA, TDMA is time division multiple access, which means that a single common channel is being used by more than one users on the basis of time division. Let us say I have 15 minutes for the purpose of transmission, in which I want to transfer some bandwidth of information from the transmitter to receiver. So, that 15 minutes will be equally distributed among n number of users. Let us say there are 4 users. So, 15 minutes will be divided among 4 users, and also there is additional time is required for the insertion of the guard interval between two users. So, that is the way which is required to remove the inter-symbol interference. Then the direction from BTS to MS is defined as the downlink and opposite direction is known as uplink. So, there are two set of frequencies is required, one is required as uplink frequency, another one is downlink. Uplink means when we are transmitting the information from mobile phone to BTS, and when we are transmitting the information from BTS to mobile phone, then that will be a downlink frequency. So, two set of frequency, which means that it is a kind of full duplex communication, where at the same time you can transmit and receive the information. Now, physical channel, when a BTS and MS communicates, they do so on a specific pair of radio frequency carriers, one for the uplink and another for the downlink. So, let us say this is a BTS. BTS is nothing, it is a kind of antenna only. It can be a omnidirectional antenna, it can be directional antenna. Generally means for the mathematical point of view, if you want to derive an expression for the power that has been received by the receiver, then omnidirectional antenna is used because it has gain is equals to 1. So, it will ease the mathematical calculation, and when we want to deliver information in only one direction, then directive antenna is used. So, here we are considering a directive antenna, this is a BTS and here we are using a mobile equipment, that is mobile phone. So, two set of frequencies is required, this is known as uplink frequency from mobile phone to BTS, and this is known as downlink frequency from BTS to mobile phone. So, let us say this is 6 gigahertz of frequency and this will be 4 this is 4 gigahertz of frequency, this will be 6 gigahertz of frequency. So, this is the case where we are using a set of frequency for the purpose of transmission and reception, and within a given time slot. So, this combination of time slot and carrier frequency forms what is termed as physical channel. Physical channel means allocating a set of frequency for uplink as well as downlink. Now, one RF channel will support 8 physical channels in time slot 0 through 7. So, 0 to 7 different RF channels will going to communicate within a single physical channel. Now, next is logical channel. The data, whether user traffic or signaling information, it can be two types of information, it can be traffic. Traffic means the data or the speech signal that you want to transmit, it does not contain any kind of synchronization data. And why synchronization or signaling data is required? Because in case of communication, definitely modulation is done at the transmitter side and demodulation is done at the receiver side. For the purpose of this modulation and demodulation, we require a carrier signal carrier frequency. So, whatever signal we have used at the transmitter side, the carrier signal, the same has to be used at the receiver side. So, what it does, it will provide the synchronization, and if it is different from what we have used at the transmitter side, then the received signal, the demodulated signal will not be same as that what we have modulated, the original signal. So, that is the case we require synchronization bits when we are talking about digital communication and signaling information or signaling synchronization signal in case of analog communication. So, the data, whether it can be a traffic or signaling information, are mapped to onto the physical channel by defining a number of logical channels. So, that is the concept, the connection between the physical and the logical channel. A logical channel will carry information of a specific type, and a number of these channels may be combined before being mapped onto the same physical channels. So, large number of information has to be carried which is of some specific type, and the number of these channels will be combined together to map onto the same physical channel. So, for example, speech is sent onto the logical channel, the traffic channel, which during the transmission is allocated a certain physical channel, say TS6 on carrier 0. So, the logical channel are divided into two groups, that is control channels and traffic channels. Control channel is used to transmit to accommodate the Synchronization information and traffic channel is used to transmit only the traffic or the data that you want to actually deliver the information. So, this is the diagram which is showing this how this logical and physical channel is there, like you can see that 7 to 8 different logical channels will make up a single physical channel. So, you can see over here that this is a TDMA frame. Now, each frame is having from 0 to 7, means 8 bits are there. So, TDMA frame will be is equals to 4.615 millisecond, which will constitute a time slot, and that will be equivalent to 577 microsecond. This will be the time slot that you want to transmit. Now, this logical channel is basically going to deliver the information. So, there are different. So, this is the broad sense of physical and logical channel. Now, these are divided into these many number of channels, which we are going to discuss in the coming slides, like FCCH, SCH, FACCH, that is related to control signaling control channels, then BCCH, RACH. So, these are the channels that we are going to study, that is related to the logical channel. Now, this is the flow chart which is flow diagram which is showing the logical channel, like this is traffic and signaling. Now, this first we will see signaling. Now, signaling is can be used divided further into 3 categories, like first one is broadcast, common control and dedicated control. So, what is broadcast? Broadcast means you want to there is one transmitter and more than one receiver is there. The same case where we are going to broadcast some information in like the FM radio, it is a kind of broadcast only. A single channel will be listened by is listened by more than one user. So, that is the case of broadcast. So, this is FCCH. The full form of this FCCH is frequency correction channel. Then this will be SCH, that is synchronization channel. BCCH is broadcast control channel. This is paging channel, that is PCH, which comes under this common control signaling. Then RACH, that is random access channel, access granted channel. Then this there will be a standalone dedicated control channel, slow associated control channel, fast associated control channel. So, these are all related to this signaling type of channel. Now, when we are talking about this traffic channel where data has to be transmitted either in the full rate or the half rate. Full rate means the full data rate is being used for the purpose of transmission. So, that will be 22.8 kbps, and half rate is exactly half of this full rate, that is 11.4 kbps of traffic data. So, that is related to the logical channel. Now, traffic channel is the traffic channels are intended to carry encoded speech or user data. Control channels are intended to carry signaling and synchronization data between the base station and the mobile station. So, logical are used by the system and the MS are used for different purposes. So, that is the concept behind this control channel. Now, we are going to discuss each channel in detail that we have shown in that we have seen in that particular flow description. So, traffic channel, these are intended to carry encoded speech and user data. So, whatever original data, why I am saying that the actual speech signal that you want to transmit, if you want to make up a call, then that is known as a traffic data. A traffic means the data which you want to transmit, the channel through which you are going to transmit is known as traffic channel. So, full rate traffic channel is there which will be supported at a bit rate of 22.8 kbps, and half rate will be supported at 11.4 kbps of speed. Then speed channels are defined for both the full rate and half rate channel. Data channels support a variety of data rates, that is 2.4. So, that is the standard value, these three are the standards value, that is 2.4, 4.8, 9.6 kbps on both half rate and full rate traffic channel. The 9.6 kbps data rate is only for the full rate application, and other, that is 2.4 and 4.8 can be used for half rate case. Control channels carrying the signal information between the MS, that is mobile system, and BTS, that is base transceiver station. Transceiver station means it will act as a transmitter and receiver at the same point of time, since it is a full duplex communication. So, there are several forms of control channels in GSM, and they can generally be divided into 3 categories. So, these are broadcast, common control and dedicated control channel. So, broadcast control channel are transmitted in downlink direction only, that is only transmitted by the BTS. So, broadcast is only being directed in one direction. So, that is not comes under the full duplex case, that is comes under only the simplex case, where the transmission is unidirectional. The broadcast channel are used to broadcast synchronization and general network information to all the MS within a cell. Such a location, area identity and maximum output power is there. It has 3 types, that is FCCH, frequency correction channel, SCH means synchronization channel, BCCH is broadcast control channel. So, first one is FCCH, frequency correction channel, used for frequency correction and synchronization of a mobile station. So, when we are transmitting the extra bits for the purpose of synchronization, so these extra bit means that we are going to check the parity bits of the bits that has been received, that comes under the cyclic redundancy check. So, that any error if occur, then it will can be removed. So, that is the case of this frequency correction channel. The repeated transmission of frequency burst is called as FCCH, that is frequency correction channel. This serves 2 types, one is to make sure that this is BCCH carrier, the other is to allow the MS to synchronize the frequency. Now, FCCH is sorry, transmitted on downlink point to multi-point, that is the case for broadcasting, and FCH burst is there. Next one is the synchronization channel. So, in this case it will allows the mobile stations to synchronize time wise with the BTS. Repeated broadcast of synchronization burst is called as SCH. So, the MS receives the TDMA frame number and also the base station identity code, that is BSIC of the chosen base station. So, BSIC can only be decoded if the base station belongs to GSM network. SCH is transmitted on the downlink point to multi-point case. So, basically what this synchronization means, that it will going to synchronize the time wise means at repetitive time with the BTS. So, synchronization is every time is required, since we are talking about mobile communication, then which means that is not related to only mobile phone. Mobile communication means the transmitter and receiver both are mobile in nature. It can be experiment where antennas are mounted on a car and we have to perform some type of experiment for some research point of view. So, that is also a case of mobile communication, where some signal is being transmitted from the antenna mounted on the car and it has to be received with to a receiver that can be moving or it can be static also. So, in that manner every for after some small amount of time, the synchronization has to be maintained between the transmitter and receiver, so that the proper reception of the signal will take place. The MS receives the TDMA frame number and also the base station identity code BSIC of the chosen base station. So, that is the identity related to the base station with which the transmitter is transmitting the information. Now, next one is BCCH. So, the broadcast control channel is used to broadcast control information to every mobile phone within a particular cell. This information includes details of the control channel configuration used at the BTS, a list of the BCCH carrier frequencies used at the neighboring BTS, and a number of parameters that are used by the MS when it is accessing the BTS. It use normal burst. Broadcast control channel BCCH include the location, area identity, maximum output power allowed in the cell, and the BCCH carriers for the neighboring cell on which the MS will perform the required measurements. So, BCCH is transmitted on the downlink point to multipoint also. Now, the MS is turned to a base station and synchronized with the frame structure in this particular cell. The base station are not synchronized to each other. So, every time the mobile phone decides to camp on another cell, its FCCH, SCH and BCCH have to be read. So, that is the case with the broadcast control channel. Now, next comes the common control channel. So, common control channel is used by the MS during the paging and access procedures. Common control channels are of three types, like first one is PCH, then RACH random access, then AGCH access granted channel. So, first one is PCH, that is within a certain time interval the MS will listen to the paging channel PCH to see if the network wants to get into contact with MS. So, for every PCH paging means, paging is basically a concept where a very small message has been floated, is to be floated among a number of users, and whichever this message is associated, the person will perform that specific action. So, that is paging control. So, at every fixed time interval, it will going to ask the mobile station that any kind of network is to be set up or not. When it requires to set up an network, then the particular network will be set up. So, the reason could be an incoming call or an incoming short message. Basically, PCH is related to a very short message like 3 to 4 letter word. Then the information on PCH is a paging message including the MS identity number, IMSI number or the temporary number TMSI. PCH is transmitted on the downlink on point to point, that is point to point communication it can be used, and it can be used for broadcasting also. It use normal burst. Normal burst means no additional information has been added in the particular type of frame. Next one is RACH. If listening to the PCH, the MS will realize it is being paged. Paged means the message is itself, it is known as page. The MS answers requesting a signaling channel on the RACH random access channel. RACH can also be used if the MS wants to get in contact with the network. Example, when setting up a mobile originated call, RACH is transmitted on the uplink, that is point to point. It is termed random because there is no mechanism to ensure that no more than one MS transmits in each RACH time slot, and there is a finite probability that two mobiles could attempt to access the same RACH at the same time. So, it uses the access burst. Next one is AGCH, that is access grant channel, is carried data which instructs the mobile to operate in a particular physical channel. The AGCH is used by the network to grant or deny an MS access to the network by supplying it with details of dedicated channel, that is TCH or STCCH, to be used for subsequent communications. The AGCH is basically a downlink only channel. It uses normal burst of information. So, that is related to the access grant channel. So, we have discussed about control channel and traffic channel. So, control channel is basically when we want to transmit the information to control the way the communication has, the link has been set up between the transmitter and receiver. So, in case of this AGCH, what it is, the access grant channel is carried data which will going to instruct the mobile to operate in a particular physical channel, that is since GSM is based on TDMA, there are time slots are allocated to each of the user in which they can transmit the data for. So, it is time specific, it is not frequency specific. So, after every time interval it will going to access the TDM, or it will going to access the mobile phone for the purpose of transmission. The AGCH is used by the network to grant or to deny an MS access to the network by supplying it with details of dedicated channel. That is, it can be a TCH or STCCH for subsequent kind of communication, and it is only used for downlink only channel. Downlink means when we are transmitting the information from BTS to the mobile phone, it is not, it cannot be used for the uplink communication, and it is again using a normal burst of information. These are the references that you can consider for this particular topic. And in today's lecture we have discussed about different types of control channels and traffic channels. Thank you.